All right, today we're reviewing all the word problems we've looked at this week. We've looked at distance equals rate times time problems. We looked at mixture problems. So today we're reviewing. I gave you a 10-part homework assignment. I'm going to do the second 5. We did the first 5 in class, so I'm going to do the second 5 right now. Just so you can see them, see how they're worked out. The test will cover these problems, so we one of each of these problems on the test. So let's go ahead and get started. I'm looking at the worksheet. I'm looking at the second 5 problems. I'm going to start with that second number 1 that's at the bottom of the sheet. It says Stephanie's car averaged 26 miles per gallon of gas on her trip. What is the value of X in gallons of gas? Okay, this problem should be an easy kind of problem. They told us here that the car averaged 26 miles per gallon of gas on her trip. And they gave us a chart that actually told us that too. If I want 5 gallons of gas, I can go 130 miles. Well, what does that mean? That means for every 1 gallon, I went 26 miles. In fact, you can divide 130 divided by 5. 130 divided by 5 is 26, and you get that 26 back. Same thing, 260 divided by 10 is 26. 390 divided by 15 is 26. And 546 divided by 26 should give me X. So if I want to find X, I just take 546 divided by 26 and see what I get. 26 goes into 54. Let's see, twice. That's 52. 26 goes into 26 one time. 21. So the answer is 21 gallons of gas. And that's basically 3 points on the test. Something like that is super easy. Should be able to do that. Second problem says Arnold drove 65 miles on the expressway in 2 hours. The rest of his trip, 10 miles in the St. Paul metropolitan area, took an additional half an hour. What was his average rate of speed for the entire trip? We've got a distance equals rate times time problem. I want to figure out what is the total distance, what is the rate, that's actually the question, this is what I'm looking for, and what actual total times I take. So if I look at the problem, which you can see on your own paper right now, total distance. Arnold drove 65 miles in 2 hours, and the rest of his trip is another 10 miles. That's my distance. My rate, I don't know, that's what I'm looking for. My time, the first part of my trip took 2 hours. The second part of my trip took half an hour, so 0.5 of an hour. And now I have my total time, my total distance. I'm going to solve for R. 65 plus 10 is 75 equals R times 2.5. How do I solve something like this? R times 2.5 equals 75. Undo multiplication by division. And I want to see how many times 2.5 goes into 70 and 75, and it turns out it's 30 times. Rate, 30 miles per hour. I'm going to look at number 3 now. Number 3 says, a freight train leaves Chicago traveling west at 1,128 miles per hour. 1 hour later, another passenger train also going west leaves Chicago on a parallel track at 1,488 miles per hour. How far are the trains from Chicago when the passenger train catches up to the freight train? Alright, we've done this problem a couple times. I'm going to show a little bit different way to do this problem. Usually we just set up D equals RT equations, and since the trains are going to catch up, we'd have 2 D equals RT equations, and I'd set them equal. But what I'm going to do is I'm going to show a little bit different way. I'm going to make a table that's more like the mixture problems that we did yesterday. And maybe this will make it make a little more sense. So here's what I'm going to do. I'm going to take the rates of each train. I'm going to multiply by its time. And I want to get its distance here. I know the distances will be equal, so these numbers in these boxes should be the same. Shouldn't be the same, they should be equal, and I can use that to solve the equation. It tells me the rate of the first train is 1128. I don't know the time, so I put T. Distance is just rate times time, so this is 1128T. The rate of my second train is 1,488. The time, it says that it's going to take me, that this train left 1 hour later. It means I have 1 hour less to drive. Now what I can do is multiply these two together. 1488 times T minus 1. I know it's kind of hard to see, but I'm going to rewrite it in just a second. I know my distances are the same. That's what the whole thing is. If the trains catch up to each other, the distances they went are the same. So I set those two equal to each other. 1128 T from here equals 1488 T minus 1. Okay, and I can start solving this equation. 1128t equals 1488t minus 1488. And now I can start solving this thing. Bring all my t's to the same side, so I'm going to subtract 1488t. When I subtract these, I'm going to get 0, I'm going to get 6, I'm going to get 3, negative 360. I want to see how many times that goes into negative 1488. So I divide. This is a t. I was looking at what I was forgetting. There's my t. Divide by negative 360. Divide by negative 360. And I'm going to get t equals. How many times does 360 go into 1480? It's not going to go in that nicely. But maybe we can figure this out. 360, maybe 4 times. I don't know. I'm going to check this before I actually do it. 360 times. Well, I'm going to go by 3. Check that one first. 0, 18, 1, 9, 10. 3 times 6 is 18. Carry the 1. 3 is 9, 1, 0, 8, 0. 13. If I add 360 to that, am I still below? 0, 4, 4, 2, 1, 1, 4, 4, 0. Alright, so it's going to be about 4, 1, 4, 4, 0, and I'm going to get 4, 8, 0. 360 is going to go to 480 one time. 360, 1, 2, 0. Is it going to go into 1200 3 times? And now I'm just going to get a decimal. I'm not going to worry about too much, but my t is 4.13 hours, so I'm going to say about 4 hours. The question asks, I'm going back to the question, how far are the trains from Chicago when the passenger train catches up to the freight train? And if I want to know that, I need to actually plug this number in, this 4 point whatever, and plug it into one of the equations. So what I would do is I would say, I go back up to these distance equations, like this one, 1128t times t, which is 4.13, and that would tell me the distance. And 4 times 11,000, I could actually sit here and figure this out. You could figure this out too. It's going to be about 4 times 1100 is going to be about 4,400 approximately. We're going to come back and look at the mixture problems in just a second.